Yo, 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 kinetic molecular theory. So what does kinetic mean? The kinetic theory states that the tiny particles in all forms of matter, solid, liquid, or gas, are in constant motion, y'all. So there are 5 postulates that the kinetic molecular theory follow. Postulates are just like rules. So the first one, gases are made up of tiny particles far apart relative to their size. The volume they occupy is not important, inconsequential. Volume is mostly empty space, and this explains why gases are compressible, as you guys can see from the picture here. The second postulate states that gas particles are in continuous, rapid, random, and that's the key there, random motion. As a result, there are collisions with other molecules or with the wall of the container. This creates something called pressure, and we'll dive into that later. Increase in temperature increases the movement of the molecules and thus the pressure exerted by the gas. Postulate 3 states that there are no attractive forces between molecules under normal conditions of temperature and pressure. Gas molecules are moving way too fast for this to occur. And then gas molecules are too far apart, so there are no attractive forces. Postulate 4 states that collisions between gas particles and container walls are elastic. What does elastic mean? Essentially no loss of kinetic energy. Kinetic energy can be transferred between 2 particles during collisions. Thus, the total kinetic energy remains the same as long as temperature remains the same. Postulate 5 states that the temperature of a gas depends on the average kinetic energy. And right here, y'all, I'm going to be emphasizing it by underlining that it is the average kinetic energy of the particles of the gas. Okay, so all gases at the same temperature essentially have the same average kinetic energy. The energy is proportional to the absolute temperature, so if one goes up, the other one goes up as well. And here I want to use this phrase, y'all. Heat up, speed up. So if the temperature goes up, then we know that the average kinetic energy of the particle of gases will increase as well. Okay, so we have here absolute temperature is the temperature measured using the Kelvin scale, where 0 is absolute 0. So what does 0K equal to? Negative 273 degrees Celsius. With the conclusion of the kinetic molecular theory, let's dive into the gas laws. We're going to be covering Boyle's and Charles' law today. Before diving into the laws, let's make sure we know these 3 variables very well. The first one is volume. So volume is the amount of space a gas occupies. Temperature is the average kinetic energy. And again, I want you guys to truly grasp that average, okay? Average kinetic energy. And then pressure is the number of collisions of gas particles with the walls of the container. So the more collisions against the wall of the container, the more pressure there is. Throughout this unit, we're going to be using the guess method to solve math problems. What is guess? Well, it's not guessing at a correct answer, it's a method, y'all. G stands for identify the given, so we underline and create an organized list. U stands for identify the unknowns. We put a box around that, and there's usually just one unknown that we're looking for. E, identify the equation needed to solve for the unknown and isolate the unknown variable. S is substitute givens into the equation. And finally, the second S is to solve. Type the values into the calculator. Let's dive in here. So we have Boyle's law. Boyle's law is dealing with the volume and pressure variables. So we see here as volume increases, we see that volume decreases. I want you guys to make sure you guys are drawing the graph here in the space in your notes. And again, when we multiply these values together, we see that the values are constant. Okay, so there we have it, the constant. With that said, y'all, we can state that the pressure and volume of a gas are inversely related. At constant mass and temperature, would this be true? And if volume increases, then I know that pressure decreases. One goes up, the other goes down. This can be represented by an equation, y'all. We have P1 V1 equals P2 V2. This was created from the previous slide. I said PV, when multiplied together, creates a constant. So we can set these two equal to each other, but differentiating by the two different values. Let's solve a gas law problem. A gas occupies 100 milliliters at 150 kilopascal. Find its volume at 200 kilopascal. I want to note that this kilopascal is pressure. Okay, so let's do that. Let's do the guess method. We underline all of our givens. The second thing is to box our unknown. Okay, so let's do that. Create the list. Boom, P1, V1, P2, V2. So again, this is the guess. We are going to box what we're looking for, V2. Now for our E. So we know that as we increase pressure, we should predict that our value will decrease. So our equation, P1 V1 equals P2 V2. I am looking for V2, so I need to isolate V2 by dividing both sides by P2. So this gets us a rearranged equation. V2 equals P1 V1 over P2. Next step is to substitute. So we plug in our numbers. We notice that kilopascal cancels each other out, and we're left with the unit milliliters. I type this into my calculator, and I get V2 to be 75 milliliters. So we have Charles' law now. Note that Charles' law deals with volume and temperature. As we increase our volume, the temperature also increases. And when we divide these values, y'all, note that these are constant values. So we can set it equal to a constant if we divide these values. So I want you guys to draw this graph here and write these guys down. The volume and absolute temperature, Kelvin, of a gas are directly related. And this is true at constant mass and pressure. If temperature increases, then I know volume increases. One goes up, the other goes up as well. So the equation you guys see here, V1 over T1 equals V2 over T2. Well, I don't like fractions, so we can cross multiply. Okay, and when we do, we get this rearrange equation, V1 T2 equals V2 T1. So this is the equation I want you guys to write down. So we will always use absolute temperature, aka Kelvin, when working with gases. So this is the scale. We're going to be using this scale. Usually our values are given in Celsius. So to convert, we need to use this equation here. Kelvin is equal to Celsius plus 273. So let's solve a problem. A gas occupies 473 centimeters cubed at 36 degrees Celsius. Find its volume at 94 degrees Celsius. So these are my givens. I'm looking for the final volume. So let's list it out. Notice, y'all, I added 273 to get this value. I'm looking for V2. I add 273 to get this value here. So now let's look at our variables. I notice that temperature increased, so I know my volume should increase from 473. Equation time. V1 T2 equals V2 T1. I am looking for V2, so I need to divide both sides by T1. This cancels out, and my new equation is as seen here. Okay, so now time to substitute. I plug in my values and notice that Kelvin cancels out and I have this unit remaining. Type it into the calculator and I get V2 to be 562 centimeters cubed. And there we have it, y'all, for today. Tomorrow, we're going to be doing the gas law lab stations. And then the next day, we're going to complete this gas law notes. Have a good one.